Hello everybody, and in this presentation we're going to be talking about more on induction, including indirect proofs, tautologies, contradictions, contingent statements, and analogical reasoning. So first up we're going to be talking about indirect proofs, or what's called a reductio ad absurdum. And in a reductio, what you do is you assume just the opposite of what it is you want to prove true. So you assume that what you want to disprove is true. Then you show that if what it is you want to disprove is true, it leads to some sort of absurd conclusion. Okay, so here's a rather amusing example of a reductio ad absurdum, where Sheldon rather defines what a reductio is. So if you just click on the little image there, right here, that'll be a link, and it'll open you up to a video or to a new browser screen, and you'll be able to watch the video. Clicking then back into this browser should restart this presentation. I'm going to pause for a couple seconds so you can do that. Okay, a tautology. A tautology is a statement that is logically or necessarily true. So here are some examples. Either Alice won the game or she did not. It's raining outside unless it isn't. And oftentimes tautologies are of the form P or not P, although that isn't always the case. And what you should notice about these is that they are always true. And they're not just always true, they're true by logical necessity. They absolutely must be true. Now you might say things like, well, couldn't it be in between if it's raining outside unless it isn't? For example, what if it's kind of misty? Well, as soon as you define what it is to rain, what level of moisture you need, then it's true that either it's raining or it isn't. Since that one's of this form here, we don't even need to worry about the content here. What you're saying is either P or not P. Either P is true or P is not true for whatever you put in the blank, for any meaningful statement. Okay, contradictions are the exact opposite of a tautology. A contradiction is a statement that is not just false, but false by logical necessity. So here are some examples of contradictions. Alice won the game, and she didn't win the game. It's raining outside, and it is not raining outside. And lots of times these look like this: P and not P. So you can't have something be true and be not true at the same time. This is called the law of non-contradiction. It's a basic rule of logic. They don't all look exactly like this. For example, here's one. There's an exception to every rule. You might have heard this before. But if it's a rule that there's an exception to every rule, then that means there must be an exception to that rule. But if there's an exception to that rule, then there's a rule that there's no exception to. So there is an exception to every rule. You end up with a contradiction. So you got to look for things that contradict. Okay, contingent statements. So we talked about tautologies, which are statements that are necessarily true, and we talked about contradictions, which are statements that are necessarily false. So what are left? Well, statements that are neither necessarily true nor necessarily false. Instead, whether or not they're true or false depend upon some facts about the world. And these are sort of the vast majority of statements. So here are some examples. Brazil nuts are really seeds. Saturn is further away than Mars. Or Alice won the game. It's raining outside. Anything that really requires observation of some kind is going to be a contingent statement. Arguments by analogy are inductive arguments. They essentially say that since two or more things are similar in some respects, they're also likely to be similar in some other respects as well. So here's an example. I burned my finger once on a 350-degree cake pan while taking it out of the oven. Therefore, if I touch the cookie sheet currently baking in the oven, I will get burned as well. I'm drawing an analogy between the cake pan in the oven and the cookie sheet in the oven. Now, I'm doing this based on the fact that they're both made out of metal, they're both very hot, and properties that they have in common. And in this case, the analogy is a pretty good one. It's pretty strong. But you need to be careful because not all analogies are good ones. If instead I was talking about a piece of styrofoam heated to 350 degrees and compared that to a cookie sheet, even though the styrofoam is something in an oven heated to 350 degrees, if I touched it, I likely wouldn't get burned, or at least not very badly, because it doesn't transfer heat the same way that metal does, even though it's the same temperature. And in fact, this is how firewalkers can walk on very hot coals for brief periods of time without getting burned, because certain wood chips, if they're laid flat, don't conduct heat very well. However, if you put aluminum foil or something over that, they would get scalded very, very badly. Statistical induction. This sort of argument uses the idea that since a particular percentage of a sample group has a certain property or properties, a similar percentage of the overall group does as well. So here is an example. Out of 200 people surveyed in the U.S., 112 of them could swim. So 56% of the U.S. population, roughly, can swim. As a statistical induction, if we have a random sample of the population, this is probably pretty good. I mean, the math works out. If we grab 200 people, that's a decent sample size. With so many millions of people in the U.S., you might want a larger one, but it's not a terrible sample size. We didn't just sample 2 or 3 people, so it's not really bad. But notice how this could be thrown off if we don't know anything about the sample. It might be a very bad induction if I only ask people on the West Coast. Because, people living on the coastline of California, for example, probably go to the beach a lot and are probably more likely to know how to swim than if I were to ask people who, say, live in the middle of the country. So it all depends on whether or not you have a good sample when you do something like this. So that's something to be careful of. And that's the end of the presentation. I'll talk to you next time.